Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Find first and last position of element in sorted array. So in this question, I'm giving an array of integers nums. It's sorted in non-decreasing order. And I will find the starting and ending position of a given target value. Starting and end position of a given target value. Okay. If target is not found in the array, return -1, -1. You must write an algorithm with overlog n time runtime complexity. Okay, so in this question, I'm given an integer array nums, and it's sorted in non-decreasing order, which means that it may have duplicated values which are adjacent to each other. And I will find the starting and ending position of a given target value. Good. So in this question, the input should be the integer array nums, which can be empty. Yeah. And I will also be giving a target integer. And the output of my function would be the list of 2 indexes. Yeah. I mean, the rest of integers. Okay. Good. So let me think of this question with some examples. Okay, so in this case, let's say I'm looking for target, say 3. So the output I'm expecting is, because 3 appears here to here, I should return 0, 1, 2, 3 to 5. Yep. So this is what I'm expected to do. And if target is 4, because it doesn't appear in the list, I will return -1, -1. So the brute force approach I've just come up with is I just traverse element in a linear scan. So I will take a look at each element, and the first time when I find 3, in this case index 3, I will memorize it, or I should keep track of it. And also I will go through the array and I find 2 more 3s. Then at the moment when I find the number 5, I can say index 6 minus 1 is 5, is the last index of the 3. So yeah, that's what I should return at that moment. But this approach takes overwhelming time because I do the linear scan on the nums array. So I can come up with a better approach. Okay. And obviously, because this array is sorted, I can use the binary search. So let's say if I'm looking for target 3, the first thing I can do is I define the scope to be searched with low and high. Then every time in that low and high scope, I will take the middle one. Yep. And if that middle number is larger than the target, I will take a look at the later numbers. And if it's smaller, I will take a look. The middle number is larger, I will take a look at the previous numbers. So and if the number target, I mean bindow number is the target, I will do some trick. So if I'm looking for the first three, and if I find the middle number is 3, it means that the first 3 can be that middle index or before. So in that way, I could, yeah, the scope I have to take a look is now becomes half. And say if I'm looking for the last 3, and if I find the middle number is 3, it means that the last 3 is that middle index or later. So in that way, also I can, the scope I'm searching for, I mean, the scope in which I'm searching becomes half. So in that way, every time I choose the middle number, the scope I have to look for becomes half. Yeah. So I can say this approach takes over log n time. And for space complexity, it should take constant space. Okay, so that being said, let me get started with implementation. So now I've written the main method, and my remaining task is to implement the two, methods. Okay. So I will start with the first index. So first, as I said, I begin with low index 0 and high last index. Then I will take a look at the, these two numbers until it has the range. Maybe I will tweak this equation later. I mean, operation, yeah, comparison. Then, as I said, because I'm looking for the first number, so when I'm looking for the first number, I can say, I can rephrase this search with something like, I will look for the first index which meets target is, no, number is larger or equal to 3. So I will tell it again. So I'm looking for the number which is equal or larger than 3. So numbers which meets that condition are these. Yeah. So my task is to find the first, true. This makes the thought process much, easier to think. So So as I said, if the middle number is here, the number I'm looking for is greater than the middle. So I will implement this first. Otherwise, say the number is middle or larger. Sorry, middle number is the target or larger. It means that the first, you know, number, no, first target is that index or right before. Yep. Okay. So this is it. So in that way, I can reduce the scope. So it's a bit confusing how I finished this. Yeah. Because if low is equal to high, what happens is that middle is always equal to low is equal to high. And if that number is smaller than or equal to the target, no, sorry, larger than or equal to the target, high is still the same value and it keeps, yeah, while loop continues infinitely. So I reduce this. So in that way, I finish with single number. No, what I'm saying. So let me think. Okay, so let me say in this way. Think of in this way. So if low is equal to high, what I will do is if the number is target, then I will return that index. But if not, I will return -1. So yeah, that being said, let me make it out of the while loop. In this way, here, low should be equal to high. Then I will take a look at this number. I think it's the most simplified approach implementation. Okay, this is it. Okay, good. Wait, so if I do this, okay, good. Yep, so now I will implement the find Rust index. So basically what I will do is the same. I copied this implementation, but the only difference is that when I try to find the last index, the Boolean gives it, sorry, I mean, so if I'm looking for the last 3, which means I can rephrase this question as I will look for the last index of the numbers which is equal or smaller than 3. So that being said, the numbers which is equal or smaller than 3, so I replace the Boolean in this way. Yep. Then so as I said, I will take a look at the middle number, and if I will delete this. So if middle number is equal or smaller than the target, which means that the condition is true, the number I'm looking, the index. Wait, if I'm looking for the last index, yeah. Oh, sorry. I'm looking for the last index of true. Yeah, last index of true. Target. Sorry. So this is good. So if the middle number is 3 or smaller, which means that the index I'm looking for is that index or later. Yeah. Otherwise, when it is false, the index I'm looking for is before the middle index. So high should be middle minus 1. So in that way, I will, reduce the scope of the possible index. And when it is reduced, limited to only one index, which means rho is equal to high, I will take a look at an index. And if it is, true, no, sorry, it is the target, I return it. But if not, I will return -1. And one thing, I try to confirm if this middle is, low and high relationship is always keep becoming smaller. So the case I'm wondering is if these two numbers are high is rho plus 1, in this case, the middle becomes 2. Yeah. And when low is equal to middle, in the case of line 61, low becomes middle. So low is still 2, which means that the scope is never be reduced in this case. But in line 63, high is middle minus 1. So it becomes, high becomes 3, 2 minus 1 is 1. So high becomes smaller than, low. So this isn't good. So the approach I can take is I will do +1 here. Oh no, sorry. I can do +1 divided by 2. So in this way, in this case, middle becomes 3. Yeah. Which means that if low, in the case of line 62, low becomes 3. So low and high should be 3 and 3. It's okay. And in line 64, in this case, high is middle minus 1, which means high becomes 2. So low is high is 2. So in that way, I can go out of the while loop and line 67 as that is always true. Good. Okay, so with that being said, I will quickly work through my code. So in this case, I will take a look at each of find first index and find last index. And also I try to check the case when there is a number. I will take a look at these two cases in each of them. So I think I will take a look at 4 cases. Let me shrink this in this way. Okay, so when target is 5 and target is 3, and when I'm given 1 and 5, I start with low 0. In this case, and high start with 1. And in line 42, middle is now 0. And I will take a look at nums middle, which is 2. And because this is smaller than the target, I go to line 45, and now row is middle plus 1. So this becomes 1. Yep. So at this moment, I go out of the while loop, and I will check line 49 is true. And then I go to line 51, and num's row is not target. Yeah, because it's now 1. So I return -1. Okay, good. So for this case, passed. I will take a 2, 3, 3 case. Okay, so I start with low 0 and high 2. And while high is larger than low, I will take a look at middle and I get 1. So I take a look at index 1, which is 3. And because this num's middle 3 is equal to the target, I go to line 49. And high is now middle, which is 1. Then I go back to line 44 and 45. Then middle is equal to low plus high or divided by 2, which is now 0. Yep. So I will take a look at index 0, which is number 2. So from line 40, and this 2 is smaller than the target. So in line 46, I will go to line 47, and the row is middle plus 1. Now it equals 1. Yep. And now row is equal to high is equal to 1. So I go out of the while loop and I go to line 51, and assert is true. Then in line 53, num's row, which is index 1 is 3. So line 53 is true. So I return low, which is 1. Good. So this is what is expected. Great. Okay, so now I will take a look at the find Rust index in the same way. Okay, so for the first case, I start with low 0 and high 1 in line 75 and 76. And in line 78, yep, currently row is smaller than the high. So I go to line 80. And now middle is row plus high plus 1 divided by 2. So it should be 0 plus 1 plus 1 divided by 2 is middle is 1. And I will take a look at num's middle, which is 5. And this is larger than the target. I go to line 83, and high is now middle minus 1, which is 0. Okay. And then I go back to line 78, and now I go out of the while loop because row is equal to high. Then in line 86, num's row is now 1, which is not target. So I go to line 89 and return -1. Good. Passed. Okay, so I will take a look at the final example, 233. I start with row 0, high 2, and then in line 79, middle is initiated with 0 plus 2 plus 1 divided by 2 is 1. And in line 80, because num's middle is now 3, which is equal to target, low is equal to middle. This becomes 1. Then I go back to line 78. And because still high is larger than low, I go to line 79. And now middle is 1 plus 2 plus 1 divided by 2 is 2. Good. Then because num's middle is now 3, which is equal to target, I go to line 81 and row is middle. Good. So now low is equal to middle. No, low is equal to high, which is equal to 2. I go out of the while loop and go to line 86, and num's row is now 3, which is equal to target. So I return low index, which is 2. Yep, so this is exactly what expected. Okay, so I've covered all the lines in find first index method, and also all the lines in find last index method. So I go back to while. So I will quickly check the main method is correct, and I will submit my code. So here I get the first index and the last index, and I return the rest of them. Looks good. Oh, so here low is not always equal to high. Okay, maybe I have to take care of the case, as I said. Let's say low is 2. Oh, no. I failed the case when nums is equal empty. In this case, oh, I can see that low begins with 0 and high begins with -1. So this is obviously the case I have to, yeah, work around. So in the beginning of the main method, I just array return. Okay. Now submit my code. Good, accepted. Okay, so again, each of the first index method and the find last index method takes overlog n time. So in total, it takes overlog n time. So I will quickly wrap up my today's live coding session. So today I solved the question, find first and last position of element in sorted array. And basically in this question, I'm given our non-strictly, in strictly increasing array, in ascending order. And my task is to find the target in the nums array, and I will return the list of the first index of the target and last index of the target. Yep. And in my solution, I use the binary search to find each of them. Yep. So I could rephrase this question as find first true, which means the condition. And also I could rephrase this with, in the find last index method, I could rephrase this with find last true. Yeah. And that being said, I could use the binary search, and I guess the index of first index and last index, and I could return the rest of them. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.